Okay, so we've been looking at trigonometric functions and looking at right triangle trigonometry of acute angles. And in front of us is an example application problem. And here we have the following. So we have a rain gutter. So a rain gutter is to be constructed of aluminum sheets 15 inches wide. After marking off the length of 5 inches from each edge, the sides are bent up at an angle of theta. So in front of you, you see this aluminum sheet. They did 5 inches from each edge. Since it was 15 inches, the middle piece is also going to be 5 inches. And they rotate this up. Okay, so looking at this, we want to figure out the following. We want to figure out the area of A of the opening as a function of theta. So we have in here, if you can see, we have 2 triangles. And we have a rectangle. So the area of a triangle, let's say A sub t for triangle. We know that this is 1/2 times base times height. And the area of a rectangle, it's base times height, or length times width. So we want to look at the following. We want to figure out what these lengths are. So let's look at one of these triangles here. We know that this length in here was 5 and that we rotated it up. So in our triangle, rotating that up, that's our hypotenuse. So we know what our hypotenuse is. We know that that's 5. If you look at this, this length over here, do we know what that length is? To me, that looks like that is also 5, but that doesn't make sense. Not necessarily. Doesn't necessarily have to be 5. So we don't know what that length is. And we have B here. Let's say that this is A. So this is our right triangle. And so let's call this in here theta. And so through here, we can look at, what do we need? We need base times height. So we need to know what A is, and we need to know what B is. And so looking at this, A, at this angle theta, let's use one of our trigonometric functions. So one of our trigonometric functions that has hypotenuse, let's say is sine. Let's use sine. So we know that sine of theta, this is equal to the opposite of theta, which in our case is B, all over the hypotenuse, which is 5. So we know in this case that B is the same thing as 5 times sine theta. A, we can do the same thing. So if I'm looking at A from theta, that is my adjacent side. So I would think of what trig function uses adjacent on the hypotenuse, which is cosine. So I know that cosine of theta is equal to adjacent, which is A, all over 5. So I know that my side A is equal to 5 times cosine of theta. So for our area of one of the triangles, this would be 1/2 times the base, or what A is in this case, which is 5 times cosine theta, times the height, which is B, and we found B was 5 times sine theta. So this is equal to 5 times 5, so that's 25. So 25/2 cosine theta sine theta. I don't like that they put theta in both of these spots because we don't know exactly how much theta is. If this was 30 degrees down here, this would be 60 degrees up here to make. Let me just think about this. Actually, no, by similarity of angles, those would be the same. Okay, so those are the same. Just had to think about that. Okay, so now looking at the rectangle, we know what B is. B is, we defined it right there. That is 5 times sine theta. And we know that this base is 5. So all times 5. So this is 25 sine theta. So if we wanted to find this area of the whole thing again, so the area of this gutter, let's just do A sub G. This is equal to, we have 2 triangles. So 2 times the area of each one of those triangles. So 2 times this 1/2 or 25/2. Cosine theta, sine theta, plus the area of the inside piece, which we found to be 25 sine theta. So it's nice over here. I noticed my 2 cancels with this 2. And so we found the area of our gutter. This is equal to 25 cosine theta sine theta plus 25 sine theta. And so that's just the generic formula. Now we can figure out what is the area if we had rotated up 30 degrees to form this, or if we rotated up 45 degrees, or 60 degrees is what they want us to check out. So let's just do one of them, and then I think I'll have you guys try it and do the other 2. So let's just do the 30 degrees. Well, we're just going to be plugging in wherever we saw theta in that formula we just derived. And so if we do that, we have 25 cosine of 30 degrees times sine of 30 degrees plus 25 times sine of 30 degrees. So cosine of 30 degrees going down for cosine 1, 2, 3. So that's the root 3 over 2. So we have 25 times root 3 over 2. Sine of 30 degrees going up 1. So that's 1/2 times 1/2 plus 25 all times sine of 30, which again is 1/2. So simplifying this, we have 25 root 3 all over 4 plus 25 halves, getting a common denominator. Rewriting as a single fraction, we have that this is equal to 25 root 3 plus 50 all over 4. And we're in inches. So inches squared. So that would be the exact answer. Plugging in the calculator. Just be careful when you're putting in the numerator in the calculator that you're putting parentheses around that whole numerator. So we have 25 times the square root of 3 plus 50. Divide that whole thing by 4. So we would get that this is approximately 23, depending on where they wanted us to round. So if we round it to the tenths, I'd have 3. So 23.3 squared inches is the area of that gutter if we rotate those sides up just 30 degrees. Okay, so I'm gonna have you guys try it. When theta equals 45 degrees and 60 degrees. So do it without a calculator. So show without calculator first.